Alright, the last example I'm going to go over here is how you fit a quadratic model to data, and I'm going to show you along with your graphing calculator how you can do this. There are extra examples in your book that I didn't go over. I figured if I kind of cram them all into one example, then you should be good. So once you use the scatter plot to determine the type of model, the best fit of data, there's different ways you can find your model. The easiest way is to use your calculator, which we've done before with linear models, because you get a little more specific. You know, you could take a couple points, a couple x, y's, and then plug them into your standard form of your equation and try to find an equation that way. But the problem is you may choose 2 points that are different from your neighbor who chose 2 different points. You may get a different equation, but they could represent the same points. So if you use a calculator, everybody's going to get the same values, or should get pretty close to the same values here. So here what we do is we have a table that compares the lifespan in days of a certain insect with the total population of its colony during the experiment. So as you go through these points, you have your days on the top row, which would be your x values or your list 1, and then you have the values in the second row, which is going to be your number of insects. These are your y values. So for the first part, we need to use a graphing utility to create a scatter plot of the data. So we're going to go to our calculator, and if we want to make a scatter plot, remember you need to hit the stat button. So we're going to hit stat, and you need to hit 1 for edit. If you have anything in these rows, then you go up. You should have L1, L2, L3. If not, you hit second plus sign and just erase all your memory. That'd be the easiest thing to do. Just kind of reset it. So, but we're gonna. I'm just going to go up here and I'm just going to hit clear and enter. That cleared out my row. Go up, highlight L1. Don't hit delete. That deletes the whole L1. Hit clear and enter. So what we need to do is we need to plug in all our values. So we're going to have 0, enter, 1, enter, 5, 8, 11, we have 15, 19, 24, 26. You should be plugging these in as you go along. If you ever have to pause something on here, just pause the video and make sure that you are doing the same steps. And then finally we have 30. So now we need to put our values in for our L2. This is going to be 0. We have 10. And then 36. Then we go 89, 140, 124. And notice how our values are going back down. So they go up and then they go back down, which if you just think about it, doesn't that give you wouldn't that give you a shape of a parabola? Kind of seems that it would. It's not just going to go straight up and straight back down. So we get 72 is our last one. Enter. Now if we want to see our actual data in our graph, you don't just go to your normal graph, your 10 by 10. Alright, you're not going to have anything here. You need to hit zoom and then 9, because zoom 9 is your zoom stat. So you need to hit 9, and that should regraph it. Well, where's my graph? Oh, maybe I forgot to turn on my plots. So go up here to Y1. Oh yeah, hey, forgot to turn on your plot 1. So you hit enter. So now it's highlighted. Now you can hit zoom and then 9. Ta-da! There are your points. Not a very pretty graph, but your values do go up and go back down. So what we're going to do is we're going to, so that was part A. So then for part B, we need to use a regression feature to find a model that best fits the data. If you look at your graph, this is not a nice pretty parabola. So your calculator is going to find the best fit parabola that would be possible here, which would be much more difficult if you're doing it on your own. Alright, so let's go to your stat button, hit stat, and then cursor right to the calc button, and you need to hit 5 for quad reg. And yours may show this screen, it may not. You may just have to hit enter. So I gotta go down to calculate, hit that. Yours should show that quad reg, and then there's your equation. So what that means really is that your equation is going to end up being y equals your a value. Let's go to, let's go to 2 decimal places. So we're going to say negative 0.42x squared plus 14.78x plus, minus, this is a minus 4.14. So this is your equation, and notice that your a is negative. If a is negative, does not mean that your graph is going to be opening down. So there is your equation. So let's put this in for our for part B here. So we got y equals negative 0.42x squared plus 14.78x minus 4.14. Now, if we were to graph this, well, actually we'll do that for part D. What we want to do is we want to approximate the time at which the mileage is greatest. So actually, if you want to graph this onto your equation, what you can do is you back here to your y equals, and you can type in negative 0.42x squared plus, you get a 14.78x minus 4.14, and then hit your graph button. This should give you a parabola that goes through a few of the points here. Notice you have some outliers. Okay, this point up here on top, that's an outlier because it's pretty far off your data. This point's a little bit off, that point's a little bit off, that point's off. But you have 1, 2, 3, 4, 5, 6 other points that are relatively close. Where these are actual data points. You're trying to find a model that is close to your data, represents it kind of closely. So for part C, what we're going to do is we're going to figure out at what point, at what time in the population was it at its height. So you're trying to find your max value, trying to find your maximum. Now you're trying to find your x or your y. Well, it's asking for what time, so time is going to be your days, which is x. So let's find your x value at the maximum. Second trace button, hit 4 for maximum. This is a good little review for your test next week. Hit enter for your left bound, well, as long as you're left of your max point. Choose anything to the right. That's obviously to the right of my max value. Hit enter again. And when it says guess, just hit enter. And then you get this nice, pretty, perfect max value. Where in here, your x is equal to 17.59 or 17.6 days. This would be the time at which it would be the highest. So you're going to say 17 point... Let's see, let me plug these in here. Now this is according to your model, 17.6. 17.6 days. Well, that is according to your model. If you look back at your table, 17.6, that would be halfway in between, somewhere, or in between 15 and 19. 17.6, well, your max value is not between 124 and 112. Wouldn't it make sense it'd be maybe somewhere over here? Well, this is a model, okay? This 11 is that outlier. This point right here is that outlier that's sticking out like a sore thumb in your graph. That's this bad boy right there. So go by the max of your model. At that point, it says that your max amount of insects would be 126. It's kind of gross if you think about it. I really hate insects. I can handle snakes all day long, but not spiders. Alright, so that's part C. For part D, determine whether a linear function or a quadratic function best fits the data. So we need to find which one has a better R correlation coefficient. So for our quadratic, let's figure out what our R is. So your correlation coefficient. So for the quadratic, going to say r is equal to something, and then we're also going to figure out with the linear model r is going to be equal to something. So let's go back to your calculator, and we're going to say go to stat, go over to calc, and you choose 5 for quadratic, calculate, and everybody's diagnostics should be on. If your diagnostics are not on, you might have to hit second and then 0 and then go down until you find diagnostics and turn them on. Otherwise, we're going to go back to our stat plot, our equation for 5, and let's see what our r value is. We get, well, r squared. Actually, sorry, you're getting an r squared value for a quadratic because this is a square. So you get a 0.9022. So let's write that down. So 0.9022. So we're going to check out the r squared value for your linear function also. So you go back to your calculator, hit your stat button, go to the right one for calc. Now instead of hitting 5 for quadratic, you're going to hit 4 for a linear regression. Obviously, this wouldn't make a lot of sense to have a linear model here. So go down here, calculate, and your r squared value, oh, holy smokes. R squared is a 0.30 something something something. In this case, obviously, the quadratic model looks much better. It is a much better fit. And so remember, you can always look at that r value just to double check. But when it asks you to determine which one best fits the data, obviously you could look at it and you say quadratic, it follows a quadratic form. Well, you also need to go ahead and show what your r squared values are. So that's 2.8, kind of similar to something you've done before. Hopefully you enjoy these notes, nice and short to the point. And if you have any difficulties with your WebAssign, make sure you hit me up on Twitter or WebAssign. You guys have a great day. He don't got no hair. He don't got no hair. Huh, huh, huh.